Cool. All right, before we get started, can we get a round of applause for all the great speakers we've had the last couple of days? I've had the time of my life. All right, let's get into it. I'm Patrick Fuentes. I work at the Nerdery. For those of you that aren't familiar with the Nerdery, I would be surprised, day two, but the Nerdery does custom software strategy, design, development. I owe a huge thanks to the Nerdery for flying me here, putting me up in a nice hotel, sponsoring the event. So a big round of applause for them. We do all kinds of stuff, JVM.net, iOS. I personally just do Android. So today I'm going to be talking about ARCore, and I'm going to be talking about it specifically through an Android lens. Okay, so before I get going to help with tone, just to level set, show of hands, who here has built something with ARCore already? Cool. How many of you have read about it, maybe looked through some code, but you haven't built something yet? And then how many of you haven't played around with or looked into ARCore at all? Okay, that's a really good ratio because this is going to be really 101 level overview. You know how when you dig into a new technology, how there's like 1, 2, maybe 3 weekends that you spend where there's this big amorphous blob of information, and then by the time you're done, a few weekends in, you're like, okay, there's still a lot of information, I don't know it all, but it's nicely compartmentalized and fairly well defined. My goal is to save you that 1 to 3 weekends. Hopefully when I'm done with this talk, you're gonna walk out feeling like, okay, I know what all the moving parts are and how they relate to each other, and you'll be ready to dig in. I'm gonna touch on first, just really quickly, for those of you that aren't familiar, what is AR? I'll cover a little bit about like what's possible, what we're seeing people doing already. Then I'm going to dig into the fundamental concepts of ARCore specifically on Android. And then I'll touch on some related resources that I think will be helpful for you. For those of you that already have a little bit of a background with ARCore, that last section I think maybe you'll run into hopefully one thing that you didn't know about that might be cool. Okay, so first off, just what is AR? Some people get AR and VR confused sometimes. So on the left, you'll see kind of think Ready Player One or The Matrix. You're completely immersed in this environment, which is entirely simulated. There is no real world. Augmented reality is different than that in that it is layering a simulated world on top of the real world. There are some really significant differences. I'm not going to spend a ton of time diving into all of them, but just for example, think about virtual reality. Certainly you could hold a handheld device and look into a simulated world. I don't think that's probably an ideal experience, which is why you don't see a lot of VR where people are just holding something like this. Whereas AR, that modality is really common and useful, and there are some huge trade-offs with that. For example, if I'm wearing a headset and it's strapped to my face, I need to minimize that motion to photon latency. Otherwise, people get sick really quickly. Not a thing you have to worry about with AR. So just good to know that these two things are different, and as you dig in, I think you'll start to discover some benefits and trade-offs. So what are people doing with AR? I'm just quickly walk through 3 examples of stuff that we've seen developing in the last year, specifically on mobile in augmented reality. In this first example, we can see a user is able to hold their device and explore this archaeological dig site in the comfort of their own office. You can walk around, you can move your device, see different perspectives, dive into a simulated environment, and you can see that right in the comfort of your own office. The next example, for those of you that have been following what's going on in AR lately, is kind of the quintessential, everybody's really into it for, I think for good reasons. You're walking down the street, street's great as is, but you step through this portal and you're transported to a completely different world that everyone around you has no idea exists. It's beautiful, you're outdoors, there's, I think, the Golden Gate Bridge, little virtual birds flying around. Everything's fantastic. I don't know about you, but I could watch this all day. I think it's really delightful. But I'm sure at this point some of you folks are like, maybe it's beautiful, maybe it's delightful, maybe you're thinking it feels a little bit gimmicky. And I think in this third example we can start to see some of the practical applications of augmented reality. So this is the Curate app by Sotheby's, just came out recently. So I'm walking around my office, the system gets kind of an idea of the real world in my office, detects some planes, and then bam, I'm able to place furniture that I might purchase and see it in the context of where I would put it. I can move it around, I can swap it out for different furniture, I could look at different configurations. And I think that this highlights what I think AR is really useful for. Practical applications, what I think we'll start to see in the future. All right, so we've seen a little bit about what augmented reality has going on lately, but specifically, what does ARCore do for you? At a high level, ARCore gives you information that you need to render simulated 3D environments on top of the real world. So 4 kind of big bullet points I would say that AR provides you of information. The first is the info you need to orient your virtual scene with the real world that your camera's observing. The second is something called anchors. The third is planes, which are what they sound like. And lastly is light estimation. I'll dive into each one of these on its own. So first off, when I talk about the information that you need to render a virtual scene on the real world that your camera's observing, the way that the system gets you that information is something called concurrent odometry and mapping. This jargon might sound really intimidating at first, but it's super straightforward. Concurrent just means more than one thing's happening at the same time. Odometry is sensor data, and then mapping is the system identifies visually distinct points with the camera, builds up a point cloud, tracks that point cloud from frame to frame, stitches that information together with the sensor data, and then it gives you the information that you need to do, like rotation and translation of your model objects that you're rendering on the real world. That is a ton of work, and we don't have to do it because the framework team did. So thank you, framework team. The next high-level concept of information that ARCore provides you is anchors. These are a somewhat higher-level abstraction of a coordinate in 3D space. I'll get into later why there's a higher-level abstraction, but just think of it as this is a spot that you want to track in the real world. The third thing is planes. These are what they sound like. So the system will identify what it sees as horizontal coplanar points and gets an idea of, I'm pretty sure that those points are coplanar, so there's probably a plane there. Worth noting right now, I said that horizontal coplanar points, there's not vertical plane detection yet. I say yet, if I had to bet, that'll probably come fairly soon. And then the last piece of information that you'll get from ARCore that you really want to pay attention to is light estimation. So the system will provide you with its estimate of what the ambient intensity of light is. I didn't think this was super important until I started to look into augmented reality recently. But if you look at these 2 cats. The cat on the left is lit up super brightly from light coming through whatever's on the other side of the doorway. The cat on the right is a lot more dim. Imagine if the cat on the right was lit up like the cat on the left. I would be very concerned about the cat, but more importantly for you, it would probably be pretty disruptive to your experience for your users. All right, so we talked about the information that you get from ARCore, a lot of heavy lifting it does for you. Before we dive into the core concepts, I just want to level set with you folks about what some challenges you might run into are. So first off, reflective surfaces. If you look on the left, I'm walking through my office. The system is able to detect planes faster than I could walk. On the right, the super shiny table, it's got just nothing. And admittedly, I picked a really highly reflective surface, but you can see as I pan to the left that that wooden table has just a little bit of gloss to its finish, not a ton, and the system is having a harder time picking that up than it did the carpet. And it's not just reflective surfaces. I mentioned visually distinct points are really important. if you look on the left, you'll see that the carpet with the really visually distinct pattern, it picks that up super, super quickly. Whereas the carpet that's a little bit more visually consistent, a little bit more matte, it's picking that up a bit more slowly. So good limitation to be aware of. The second challenge I want to point out is low light situations. So on this projection, it maybe looks a little bit darker than it was in reality. It's a fairly dark room, but you can see as I walk into the room, as far as the system's concerned, that plane stops, it's the end of the Earth. In reality, as we walk in, we can see that there is still a floor there. I don't look at this as much as a dig on ARCore and its capabilities. I look at it more as a testament to how amazing the human eye and visual cortex are. Any of you folks that have messed around with photography and f-stops and whatnot can understand how that is a challenging problem to solve. The third challenge I want to point out is foreground objects. So what you're rendering is going to be rendered on top of what the camera is seeing. And when I say on top of the real world that the camera is seeing, I mean on top of everything, including maybe a hand that's passing just a couple inches in front of your camera. I don't want to make a mountain out of a molehill here. Honestly, I was playing around with ARCore for weeks before I even noticed this as a thing. But some of you folks, as we're going on, might start to think of your next great idea for augmented reality. And it's just good to be aware of this limitation. If your use case is totally broken by this, then maybe think around that. The next technical limitation I want to talk about is the availability of devices. ARCore is available Min SDK 24, but it's actually much more significant than that. It's not just the Min SDK that you have to achieve. You have to have specific hardware. You have to meet specific hardware requirements to run ARCore. And you also have to be calibrated properly at the factory. So you're not going to find this on 100% of Android devices in the wild right now. If you would ask me a few months ago, ARCore wouldn't be available on any devices. Since they've gone 1.0 in the last couple of months, now 100 million devices Google is saying are supported. They're working hard to have more devices supported in the future, so this is just the start. They're working with the usual cast of characters, Samsung, Huawei, LG. This is something Google's really good at, so I believe them when they say that we're going to have ARCore available on a ton more devices fairly quickly. So I've been talking about technical challenges so far, but there aren't just technical challenges with ARCore. There are some experience challenges that aren't quite figured out. So for example, the system will give you information right away, but that information might not be great. It takes a little bit of time for it to gather better data, and it's always correcting and improving its understanding of the world. What do you do in that time until the system has the right quality of data? Also, how do you know when the system has the right quality of data? Is that a thing that you can test for? And then some of you folks that were watching really closely with the Sotheby's Curate app probably saw that there was some prompts and it was kind of hinting that I should be waving my phone around. We don't have really well-established, understood semaphores for this yet. So just know that as you're wading into this new terrain that there are going to be some things that you're going to need to work through from an experience perspective. And then not just the experience challenges. There's one big I see as I'll call it an industry challenge. Maybe a better way to put it would be helping ARCore, helping AR find its niche. I don't think that we've found all the great use cases for AR yet. I think that's because there weren't a ton of commoditized devices in everybody's pocket around the world that could support AR. So just know that we probably haven't found where AR works really well and where it just is maybe more work than it's worth, or maybe not going to be a great experience. For those of you that think, okay, well, we've probably seen everywhere that AR is going to be useful, so I don't think that I need to go and explore great use cases. I'd ask that you pay attention to voice UI. If you think back to, show of hands, who remembers Dragon Naturally Speaking? Right? So Dragon Naturally Speaking has been around forever. It's a voice transcription software. I remember trying to link that up with Microsoft Word. I was so excited in high school. I was like, I'm going to dictate all my papers. It's going to be way faster than typing stuff out. And I think they were like 99% accurate, which it turns out for voice transcription is unusably bad. Whereas the technology's gotten a lot better. And now we're seeing voice UI is becoming fairly common. Think about stuff like, well, maybe Siri's not the best example, but Google Assistant, right? I think that the technology has kind of started to arrive for the first time. So I genuinely believe that we're going to be discovering those use cases where AR really soars. All right, so I think that's everything I have to talk about with regards to challenges I think you should be aware of. Let's talk about maybe some things you want to dig into before you really get your hands dirty with ARCore. So I highlighted 4 areas. I'll walk through each of them, and then what you choose to do is up to you. First off, you probably want to get the SDK. That seems like an important one. Also, the SDK comes with a couple of sample projects in there. I recommend taking a look at those, dig through the source code, see the way they did things. Nothing too shocking there. The rest of these things the other 3 things are things I would recommend that you dig into and learn a little bit about. So I mentioned that ARCore provides you with information that you need to do rendering. So you need to do the rendering. So for those of you that aren't already 3D rendering experts, these are things you're going to want to become familiar with. Right now, ARCore is meant to work at least directly on Android with OpenGL, so we'll want to go through the journey to get comfortable with that. When I talk about going through the journey, certainly you could skip the 2 steps in the middle and just jump in and learn OpenGL. I personally am the kind of person that likes to get comfortable, feel like I understand what's going on under the hood. So first off, if you didn't have a background in matrix math at all, or maybe you had it in college and you could use a quick refresher, the second link there is to Khan Academy's bit on matrix math. Every time I go to Khan Academy, I walk out feeling like I am awesome. I totally understand this. This is not a big time commitment. You're talking about a few hours, an evening or 2 maybe. So that's a good primer. Once you're feeling comfortable with matrix math, then the next link is to a YouTube series of recordings of UC Davis lectures. These are on 3D computer graphics in general. Again, I meant you can skip this. You could just go straight to OpenGL. If you skip this and you don't have an understanding of the concepts that they teach here, you're just going to have to be comfortable accepting kind of the phrase like, well, it's just that way because that's the way we do things. You're going to learn in this course kinds of things like, wait, why do we translate an object back to the origin before we do a scale and then translate it back? You're going to see, wait, matrices represent polynomials, okay, and those are curves. That makes a lot of sense. Then lastly, I have 2 different resources I highlighted for learning OpenGL. And these are kind of pick whatever is more comfortable for you. The first one is a textbook, comes highly recommended. If you love textbooks, you'll love this. The second one is an online resource. It's a set of instructions and tutorials where you can actually be writing OpenGL 3D rendering in C. It is at least as much fun as it sounds. I highly recommend it. I've learned a lot from it. All right, so on to the key concepts of ARCore itself. If you are intimidated by ARCore, please don't be. The API surface is really small. There are fewer than 20 core classes that you really need to care about. I am going to introduce almost all of them to you really quickly. So first off is session. The session is the most important key concept in ARCore. This is your entry point to using ARCore in general. It manages some system state. It is what it sounds like. If you want a session, easiest thing on earth. Toss a context into your constructor, boom, you're ready to go. By easiest thing on earth, like so many things in engineering, there are a few other details you're going to want to care about. First, talk to the system, ask if ARCore is actually installed. There are several exceptions you want to handle, but for the most part, it's pretty straightforward. So once you have your session, you're ready to start doing cool stuff. With the session, that alone, you can already get planes. So you ask the session, hey, give me all your trackables. There are two different kinds of trackables right now in ARCore. First is planes, the other are points. Planes are the more interesting of the two. This is exactly what it sounds like, a representation of a 2D surface in the real world. Worth noting, there are two different kinds of planes right now that ARCore detects. There's horizontal upward facing and horizontal downward facing. Horizontal upward facing is just like a tabletop or a floor. Horizontal downward facing is just like a ceiling. Side note, someone please do something with ceilings. Everything I see has to do with like floors and tabletops. I haven't seen anyone doing anything with ceilings yet. Next core concept is frame. So the frame is, you can think of, it's just a snapshot in time. What is the current state of the system? If you want a frame, again, incredibly easy to get. There's an accessor method on the session. So you say, hey, give me the frame. And with the frame, you can get all kinds of useful information. So either directly or indirectly, your frame's going to provide you with your point cloud, image metadata, light estimation, all the cool stuff that you want to get from ARCore. So some of the things that you're going to want to get, I mentioned you'll get indirectly from the frame. Another object, I think this is the last object that you want to think about as an entity that has information to provide you, is the camera. So the camera, again, is easiest thing on earth to get. Say, use the accessor method on frame, boom, you're ready to go. I've been talking a lot about the frame. So the frame is a snapshot in time of the information that you have. You probably have noticed that a lot of these things I'm talking about are happening in on-draw frame. That's an open GL surface view method that you override. This is what it sounds like. This is where you're going to draw your frame. Next key concept is anchors. I talked a little bit about this before. This is a point in the real world that you want to track. It's a little bit of a higher level abstraction. And I mentioned I would explain why you want a higher level abstraction here. So you certainly could say, hey, give me the exact mathematical coordinates in 3D space of a point. You don't want that, and the reason you don't want that is because the system is constantly correcting and improving its understanding of the real world around you. And as it's doing that, you just say, give me information about that anchor, and the information is constantly being improved. Corrects for things like drift errors and whatnot in sensors. So how do you get an anchor? One great way is a hit result. This is another key concept in ARCore. So a hit result is the intersection of a ray and some real world geometry. So that might sound a little bit abstract. Why does this matter? Think about a screen on a phone. There's a 2D surface, and in theory, behind it is this 3D space. It's an artificial representation of the 3D space that your camera's seeing, but stick with me. You tap on this 2D surface, a user does, and you could cast a ray out from that point that they're touching into that 3D space, and that ray at some point is going to run into a real-world geometry, like a plane, for example. That point where their tap, the ray cast out, runs into that real-world geometry, like a plane, is maybe something you'd be interested in. So that would be a hit result. And with the hit result, you could say, hey, give me an anchor for that. I'd like to keep track of that point. Again, very straightforward. We are the majority of the way through all of the API surface of ARCore. Next is light estimation. This is incredibly straightforward. You get 4 floating point values for your light estimate. A few months ago, all you would get is your ambient intensity. So the last of those 4 values, that's just roughly how bright or dim is the area that I'm in. The first 3 values are RGB, so that'll give you a little bit of an idea of color correction. So maybe the space that you're in is really bright, but it's really bright with red light for some reason. If you have your model lit up really brightly with white light, it's going to look kind of funny, so that's valuable information. Okay, for those of you that don't have a background with 3D graphics, bear with me. This might sound kind of intense, but it's pretty approachable. Let's talk about matrices. So this is probably the most valuable information that we get from ARCore. There are 2 different matrices. If you aren't familiar with matrices, a matrix is just an array of numbers. The numbers that we're going to get, it's a 4x4 array. So it's a rectangular grid, 16 numbers, 4x4. Why do we want matrices? We're simulating a 3D space on a 2D screen. And if we want to transform, for example, between a 3D space and a 2D space, we need math. What kind of math do we need? We need matrix math. Right? So hence why we want two matrices. Making sure I'm not missing anything key. Yeah, so there are two different matrices. Let's talk about the difference between these. One is the view matrix and the other is the projection matrix. So this is a talk about ARCore. I'm sticking mainly to ARCore. This is not an ARCore concept. View matrix, projection matrix, if you Google these are just, they're 3D computer graphics things. You're going to find them all over the place, especially with regards to OpenGL. But I want to give you some hint as to what these two different matrices do. So the view matrix defines the position of the camera, the location and the orientation. So if you look at this graphic, between, step 1 to step 2, that's not what we're talking about. Step 1 is the local space for a model, a single given object. Step 2 there, that's your world space. So I have an object, and there are other objects. It's a big, crazy world. So where the view matrix steps in is between step 2 and step 3. So I talk about the camera and location and orientation. I like to think of it like this. This is a really simple way to put it. I'm rendering a bunch of stuff. How do I know whether to look at the front of it, or the left side, or the right side, or the back, or the top? I've got a 2D screen. I can only render one of those things at a time. That's what this is for. The second matrix is the projection matrix. So this, I'm checking my notes because sometimes I misspeak about this. I'm new to 3D rendering. I've picked up everything in a few months. You could do the same too. So the projection matrix steps in between step 3 and step 4. So I mentioned you have this big, crazy world full of objects, and now we know which place to look at it from, but we want to clip the space. So technically, I think a good technical description is defines the characteristics of the camera coordinate space into normalized device coordinate space. That's super wordy. A really simple way to think about it is, first off, we can think of coordinates in a lot of different numerical ways. This thinks of it on a scale from -1 past 0 to 1. So that's on the x-axis, the y-axis, and the z-axis. Why do we care about this? Because the screen doesn't show the entire world. It shows some subsection of the world. So that's the first thing that we get out of it. And then the second thing is depth of field. That was probably the most intimidating part, I think, of ARCore. Lastly, I want to talk about the humble config class. I feel like config classes don't get enough credit. I think that there's some interesting things to learn about ARCore from this. There are currently only 3 configurations available. The first 2 are turned on by default. That's, do you want to be doing light estimation, and do you want to be finding planes? If for your specific use case, for some reason you don't need either of those pieces of information, you can turn it off. I haven't benchmarked these things. I would assume there are some performance benefits to turning those off. The third configuration option is maybe a little bit more interesting, and that is your update mode. So there are 2 different update modes. One is blocking, and the other is latest camera image. Defaults to blocking. Blocking just means I'm going to ask you for information. Give me information when you get new information from the camera. The other option, latest camera image, is I don't have time to wait for the camera. 30 frames per second, I think, on most devices. I need to know what's going on now. Just give me the last camera image that you got a hold of. That is a tour of all of the API surface of ARCore, I think, that you really need to worry about to get started. So last, I think I'll talk about some resources that might be helpful as you're digging in. The first thing I want to talk about is Gapid. It's a graphics API debugger. It's a collection of tools that lets you inspect, tweak, replay calls. Any of you folks that have used debugging tools of any kind can understand why stepping in between your application and the graphics driver and being able to like stop and say, oh, I want to tweak that call, that is super, super useful. Next, I want to talk about 3D models. So you can render a lot of things with OpenGL. You probably want some sort of model to render. So maybe you have those birds flying around, those are models, or a cube, that's a model. How do you get models? There are tons of different pieces of software out there to make your own models. Maya is a big one, 3D Studio Max, Blender, SolidWorks. Which one is right for you, I think, is partly a question of your use case and partly a matter of personal opinion. I wanted to highlight Blocks since we're talking about cool new stuff. Blocks is unique in that it is a way for you to make 3D models in 3D space. So if you have an HTC Vive or an Oculus Rift, you can strap on your virtual reality headset and be like a sculptor in this virtual world. I think it's exciting and cool. So what if you don't want to make your own 3D assets? What if you would rather use 3D assets that someone else made? Maybe you have a designer who's an expert at making 3D models. Maybe not. If not, Google released something in the fall, winter called Poly. Poly is a way to find and import 3D assets that other people have made. There's a ton of functionality. It's a RESTful API with all kinds of options. For example, you can search by keyword. You can search by what kind of asset type you want. You can search by complexity. So maybe you want really simple models so you can have a ton on the screen at once. Or maybe you want really complex models because you want really high fidelity. You could fetch thumbnails. I recommend digging in, getting your hands dirty. Google has plenty of samples online, so just take a peek. Next thing I want to talk about is ARCore. Some of you are probably wondering why I'm talking about iOS at an Android conference. I don't know about you folks, but when I have to make an app, my client, whether that client is like someone that hired the company, or whether that client's my boss, or whether the client's me and I want to make my own thing, client often, if they want an Android app, will also want an iOS app. So it's a good idea, I think, to just be aware of what the capabilities are on iOS. I think that you'll find that the API surfaces are super, super similar. Kind of an extra bonus of digging into ARCore, I think. This is not a guarantee, but just something maybe a little extra. I've found that ARCore, if they have a feature that ARCore doesn't, sometimes you'll see that pop up in ARCore later. So maybe something to look forward to in the future. But at the very minimum, you want to make sure that you have an idea of what's capable on Android as opposed to iOS so that you can speak to your business stakeholders about what you're able to do easily. Last platform I'd want to talk about that isn't Android would be the web. This is kind of cool. So this is something that is live on the web right now, that URL up at the top. You could just go there and try this out. It's pretty cool. So this is something somebody built to stand up a virtual building in the real world and toss some furniture in there. I think it's super, super awesome. It's especially cool that they did it on the web. Worth noting, AR on the web right now, ARCore on the web, only works with experimental browsers. I put a link up here if you want to install a browser that'll run this on your Android device. But I think it's important to be aware of what's possible with augmented reality on other platforms, just to be able to speak to it, or maybe find inspiration. Lastly, I want to talk about, I mentioned I was just thinking straight up, stick to the basics Android. I do want to mention that you have other options if, for example, maybe you don't want to learn OpenGL. You could use game engines such as Unreal or Unity. These come with some trade-offs. So first off, you don't have to learn OpenGL. Some of you are like, yay! I would point out that just because you don't have to learn OpenGL doesn't mean you don't have to learn anything. If you don't know Unreal, you have to learn how to use Unreal. There are some other pros too. These don't just handle rendering 3D graphics. They're fully featured suites of software. They have fancy stuff like physics. So you don't have to think about that. You can think about making your cool application. I don't think that these are perfect for every use case. So say, for example, you have this mature application for IKEA or something like that, and you want to just tack on one little feature. It's one screen where people can pick furniture and just see what it looks like in their house. If you were to try to use Unreal, for example, I've tried to tack on just like one little section of an app with Unreal before in an Android application I wrote. It is not a great experience. Terrible things like catching exceptions and relaunching my app. And sure, you kind of could do that. But yeah, you're not going to have a good time if you just want one little AR feature in your application. Also worth noting, you're probably going to add something like 20 megs to your APK size if you're using something like this. Okay, I don't know if it came across, but I'm going to come clean. I have an agenda in talking about ARCore. I think AR is cool. I think we haven't seen the things that are possible with it. I don't think it's a gimmick. And I'm hoping that you folks are inspired and actually want to start messing around and building stuff with ARCore. So please do that for me, but just know that there are benefits for you too. Think about a lot of folks that are prominent in the Android development community. Maybe they're Android celebs that blog post or speak that you look up to, or maybe it's mentors that you know. A lot of those folks got in on the ground floor or somewhere close, and they've gone through the journey as the platform matured. The challenging days, gingerbread and pre-gingerbread, and stuff is really good now. And they help to define some of the conventions that we see. I think that now is the time to get in on ARCore if you want to have that same experience. We're starting to see commoditized hardware, both iOS and Android, that is going to be available in the hands of users all over the planet. If you're digging in now, whatever you're into, you can help define that for the future. So like maybe you're really into user experience, and you can help define like what the semaphores are that people expect for certain things. Or maybe you're really into architecture, and you're an architecture wonk, and you can contribute to what becomes conventions between the way that the information provided by ARCore is communicated to what you're rendering. You can help define user expectations moving forward, and I think that's super exciting. Just want to say thank you all for listening. It's been a pleasure.